All right, for prime factorization, don't be intimidated by the large numbers. Usually there's a little bit of a trick to whack that thing down to a bit smaller size. Notice that this ends with 2 zeros. So for number 20 here, for the prime factorization of 2,200, we'll get our 2,200 up here, and that can easily be written as the product of 22 times 100. Hope you're familiar with multiplying by powers of 10. And then from here it's not very difficult at all. 22 is 2 times 11, and 100, 10 times 10. So each of those would be 2 times 5. Alright, and basically you keep going until you have all prime numbers down here. Alright, so the prime factorization of 2,220, I should not have used the word and. The prime factorization of 2,200, it's for problem number 20, is 2 times 2 times 2, or 2 to the third, times 5 times 5, or 5 squared, times 11. Alright, so this is the prime factorization of 2,200. Looking at another one, 4,725. Again, don't be too put off by the large numbers. Notice it ends in 25. Alright, if it ends in a 5, you know it's divisible by 5. If it ends in 25, well, it's divisible by 25. So here's our 4,725. I know 25 goes in there. Alright, so the first step of the prime factorization is going to be 25 times something. Well, and if I don't know what it is off the top of my head, I just do some long division. Let's sneak off to the side here. 4,725. Divide this by 25. Goes once. So 25 goes into 104 times, so it'll go into 208 times. $22 left over, bring down your 5. And 25 goes into 225. Well, if that was 8 times, this is 9. Alright. Oops. 9 times 25 is 225. So nothing left over. So 25 times 189 is 4,725. This one cleans up real fast. That's just 5 times 5. Let's see. 2 won't go in there. Does 3 go in there? I hope you remember the trick. You add up all the digits. 1 and 8 is 9. Plus 9 is 18. If 3 goes into 18, 3 goes into 189. Okay? And 3 does go in there. So 189, I know 3 will go in there. And it goes in 63 times. Okay? And again, 2 won't go into 63, but if I add 6 and 3, I get 9. And 3 goes into 9. So 3 goes into 63. Okay, and it goes in, 3 goes in there 21 times. About to run out of room. And 21 is just going to be 3 times 7. Alright, so we have 1, 2, 3 3s. Where am I going to put this? I need a little more room here because I want to say that 4,725 is equal to 3 to the third power, because I have 3 times 3 times 3. Okay. I have 2 5s over here, so that's 5 to the second power. And I have 1 7 times 7. So if I multiply all these together, I'm going to get 4,725. Okay. We'll take a look at number 42 here. Write the fraction in simplest form. Basically, they want us to think of a number that will go into the numerator. It will also go into the denominator. You cancel common factors. If you can't think of anything else, I think I can zoom in on this a little. Certainly a 2 would go into the numerator and 2 would go into the denominator, but if you can think of a larger number that works, it speeds things up. Okay? It occurs to me that 6 will go into 42, 6 will go into 54. So usually I don't write this, but what I'm doing is I'm dividing by 6 and dividing by 6, because 6 over 6 is equivalent to a 1. It's a funny looking 1, but it's a 1. And if you divide by 1, you don't change the value, you just change the appearance. Okay? So this is negative. 42 divided by 6 is 7. 54 divided by 6 is 9. And I lost my negative sign. Well, I have a quick remedy for that. Equals negative 7/9. Okay. So that takes care of 25. And let's see, the next one up is, we'll look at number 27. Alright. And hopefully you can see that well enough. Again, we're still just looking for common factors. So maybe I'll write this out a little bit. I could just look at it and cancel common factors, but I'll take the extra step and just kind of show you the common factors. This is another way to think about it. 8 can be written as 2 times 4 and then s times t. Hope that looks like an s. That's a t. And 44, I'm going to write that as 11 times 4. S squared is s, come on s, times s. And we cancel common factors. Okay? The 4's are in common, so basically we divide by 4 and divide by 4. 4 goes into 4 once. 4 goes into 4 once. S goes into S one time. I have no idea what S is, but I know that S divided by S is 1. So what's left? We have 2t in the numerator. We have 11s in the denominator. Okay. Now normally I'll just go right here and do all my work right there on the fraction. The common factor is 4. 8 divided by 4 is 2. 44 divided by 4 is 11. I have 2 s's down here and just 1 up there, so the squared is gone, the s is gone. The only thing left is 2t up top and 11s on the bottom. Okay. And of course they're the same. This is how I'm usually going to do it, but this shows more explicitly exactly what's going on. Okay. So I'd suggest if you get confused, just maybe write it out more like this and cancel the common terms. I think we'll try one more of these. Maybe this one here. yeah, this might look a little bit intimidating. So I'm going to cancel it the way I like to, though. I know a 5 will go in there, but not there. 3 won't. 10 won't. 12. Well, I'll see what happens just cutting it in half. I'll probably do it more than once, though. 40 divided by 2 is 20. In fact, I'm going to get rid of this 29. It's kind of in our way here now. But that's the one we're solving, is number 29. And 112 divided by 2 is 60. Now that'd be 120. 55 would be 110, so that's 56. All right. And I can cut each of these in half, right? 20 divided by 2 is 10. 56 divided by 2 is 28. All right, see, you can just keep going. 2 will still go in there. So I'll just cross them out here. 2 goes into 10 5 times. 2 goes into 28 14 times. So I still got to deal with my variables here. But I've got 14 over 5. All right. And let's see, I have 1 h on the bottom, and I've got 3 of them up top. So I'll cancel this 1. I'll subtract 1 from 3. I'll be left with 2. So that's h squared. I have 1 p on the bottom and 2 of them up top. So I'll cancel 1 on the bottom, and I'll get rid of 1 of these. I'll be left with 1. So p is on the top. And I can extend this fraction bar all the way over. Okay. There's other ways to show this, but usually what I do is I just think of a number that'll go in the numerator and the denominator and start reducing. Okay. Obviously, I could have used something bigger than a 2, and it would have moved more quickly. Yeah, 8 would have worked, and that would have speeded things up, but that didn't occur to me. But that's simplified form, and maybe we'll just do number 31. All right. Well, now that they got me thinking about 8s, I'm going to work a little faster here. 8 goes into 56, and 8 goes into 120. I know that because 10 times 8 is 80. And I need 40 more to get to 120. And 5 times 8 is 40. Okay, so 8 goes into 56 7 times. 8 goes into 120 15 times. W up top and W on the bottom, so each of these cancel. W goes into W once. W goes into W once. This x is left on the bottom. So you have 7 times 1, but I'm not going to bother to put that. 15 times x. All right, so that takes care of 2 of those. And I think to finish out this one, we'll compare, let's pick maybe 2 of these. Basically, if you had common denominators, you would know real fast whether or not they were equivalent. So I know a lot of times people are encouraged to use cross products. I really don't like using cross products. I think it's bad form. So I would rather you just understand that you need common denominators, and you don't have to do all the work of getting them. Okay? If I multiply 5 times 11, I'll get 55. If I multiply 11 times 5, I'll get 55. So I know what to do to get common denominators. I just don't really have to do all that work. Okay? So I'm going to multiply. Let me get rid of my 33 here. So I'm going to multiply just by 11. 1 times 11 is 11. Pretty exciting, huh? Technically, I also multiplied by 11 in the denominator, but I don't really have to go through the work of doing it. I'll just put an asterisk there. I don't care what it is. Over here, I'm going to multiply by 5, and I'll multiply by 5 on the bottom, but I don't care what it is. All I care about is up top. And 11 is not equal to 10. So are the fractions equivalent? No. And this one, if I was going to multiply by 56 over 56, ignoring the denominator, and 7 over 7, ignoring the denominator, I'd have pretty big fractions to look at. But notice this can be reduced. I'm not changing the value, I'm just going to change the way it looks. 7 goes into, let's see, what goes in there? 48. 6 will go into that. 3 won't go into that, so 6 certainly won't. But 8 will. 8 will go into that, and 8 will go into that. So 48 divided by 8 is 6. 56 divided by 8 is 7. And 6/7 is certainly equivalent to 6/7. Okay? That'll take care of this one.